Hello everyone. Today I am going to explain you about greedy method. So what actually greedy method? Before going to explain about greedy method, first in general what actually greedy? Greedy means eagerness to get more. So in the same way here greedy method means eager to get optimal solution. Then what actually this optimal solution? So assume that some problems you may have more than one solution. In that situation, you have to find all possible solutions. After getting the possible solutions, you have to compare those solutions and you have to decide one solution among the all solution as a best solution. After comparison, you will get one solution as a best solution. That best solution what you call optimal solution. So now one thing you remember in greedy method, eagerness to get optimal solution. Then how will get that optimal solution? Instead of finding all the solutions and making comparison and after that deciding as a best, in greedy method you are finding only one solution and that solution is always optimal. Means here for the problem you may have more solution but here you are finding only one solution and that solution is always optimal. Not necessary to compare and afterwards tell that is the optimal. How actually this procedure works? To get that solution you have to follow some steps or procedures. So for example in greedy method, first, it works to get the optimal solution based on what? Feasibility. That is feasible. Feasible means what? Concentrate on constraints. Means what? So, first you have to see the problem and in the problem where is the condition? First you concentrate on that condition. Next is optimal. As I told earlier, among all possible solutions, finding only one solution which is optimal always. Means what? You are finding only one solution that is optimal. Next is irrevocable. Irrevocable means on each iteration, whatever the solution you will get, no, that solution is fixed. Means what? So usually to get the solution, same logic we need to execute more than once. On every iteration, whatever the solution we will get, no, that is the fixed solution and the next iteration you will get the fixed solution for the next subpart. Like that you will repeat until you will get the final solution. These are the three things you have to follow if you want to get a optimal solution. So now we'll see about some of the problems and solution for those problems under greedy method. So first problem is finding minimum spanning tree. So before going to know what actually minimum spanning tree, first we'll see what actually spanning tree. Spanning tree means what? It is connected acyclic graph. G that is equal to V comma E. V is the vertex and E is the edge. So connected means, for example, for all the vertices with minimum one edge, that you call as a connected graph. And acyclic means graph with no cycles. For example, in this graph A to C, C to B and B to A cycle is there. Then it is not a spanning tree. But in this graph there is no cycle. So then you can call this one as a spanning tree. So means spanning tree means what? It must be connected and acyclic graph. So next we'll see what actually minimum spanning tree. So if you want to find a minimum spanning tree, so to get that minimum you need to require weighted graph. Weighted graph means what? Edges with the weights. So weighted connected graph with minimum total weight here. So now this is the graph and this is the weighted graph and also the connected graph here. But here you are having the cycles, all those things. That's why you don't call this one as a spanning tree. So now your work is what? You have to find that spanning tree and after that finding the spanning tree, you have to decide which one is minimum. So for example, for this graph, we'll get the two spanning trees here. This is one spanning tree. Yes, all the vertices are connected. Yes, it is connected and there is no cycle. Yes, it is acyclic. So this is one spanning tree and this is the one more spanning tree. All the vertices are connected and no cycle here. Now you have to decide among these two which one is minimum spanning tree. So that is the add up the weights of the edges. So in this graph, 6 plus 4 plus 1 means it is 11. So weight of the spanning tree is 11. And in this graph, weight is 2 plus 1 plus 3, that is 6. So among 11 and 6, which one is minimum? This weight is minimum. So then for this graph, minimum spanning tree is what? This is your minimum spanning tree. So now your work is what? You have to find the minimum spanning tree. So for finding that minimum spanning tree, now for this graph, first I found the all the possible spanning trees. Next I compared weights of the all the spanning trees. Among these two, which one is having the minimum weight? That one I decided as a best or optimal solution or minimum spanning tree. But here my work is what now? I have to find only one spanning tree and that spanning tree must be always optimal. So that is the main strategy of the greedy method. To get the solution in that way, so two algorithms are available under this particular greedy method. First we'll see the one algorithm. That algorithm you call as what? Prim's algorithm. So this is one graph. Now our aim is what? We have to find the minimum spanning tree for this graph. It is connected graph and must be acyclic. How actually Prim's algorithm works? So now to get the solution for minimum spanning tree under Prim's algorithm. So first you have to make three columns. First column heading is what? That is caption of the first column is tree vertices. Second column is remaining vertices and third one is the illustration. So first you have to make three columns and next in the first column you start writing the vertices which are you are going to visit. Assume that at present this is the graph and all the vertices of this graphs are what now? All are now it is unvisited. So now I'll make this as a unvisited by taking as a 0. Assume that now at presented no vertices are visited. So that's why I'll take this one as unvisited. So next you have to check for the spanning tree whether it is all the vertices are connected or not and what is the weight of the all the vertex edges and based on that you have to decide minimum spanning tree here. To get the solution in the Prim's algorithm, first assumption is what? Now all are 0 and I'll start visiting the vertices one by one. You can choose any vertex. At present I'll choose this one to visit first and I'll make that one as a 1 now. So now this vertex is selected to visit. Which vertex will visit now? That vertex you have to write here A and dash dash. Usually this dash represents the adjacent vertex and what is the weight of that particular adjacent vertex edge. So at present this is the only one vertex I am visiting. No adjacent vertices are there. That's why it is dash comma dash here. So now this vertex I visited. Remaining vertices which are left as unvisited, that one you have to list here. Which are the remaining vertices? B, C, D, E, F. See here, B, C, D, E, F. These are the vertices which are not visited. So now after that you have to check adjacent vertex for the visited one. If it is visited, then only you'll get to know that this is the adjacent for that particular vertex. For at present, which vertex I visited? A now. So now remaining vertices are listed here. So now you see in the graph for the A, B is adjacent, F is adjacent and E is adjacent. So now I can see these three vertices. So that's why, so here you write B, and which is adjacent for this one as A. So for B, A is adjacent. What is the edge weight now? That is the 3. That's why it is A comma 3 here. Next, F is also adjacent to A. What is edge weight? That is 5. So that is A comma 5. Visited vertex. Okay. Next, E. For E also, A is adjacent, which is you already visited. And what is edge weight? 6 it is. That is B, E, F are adjacent to this visited vertex, which you are listed in the first column as a 3 vertices. So now weights of those edges also you are represented here. Next, C and D. These C and D are not adjacent. Adjacent means there is no direct edge from A to C, and there is no direct edge from A to D here. So if there is no direct edge means what? It is not an adjacent. So if it is not adjacent, then you take as a dash, and you don't know the distance. That's why you will take as a infinity. For D also, it is not adjacent. That's why you take as a dash, and it is infinity. So after listing all the vertices here, next you have to choose among all these vertices. You have to decide which edge weight is minimum. So now for these vertices, weights are also represented here. That is 3, 6, 5, infinity and infinity. Assume that infinity means what? It is very large value. So now 3, 6, 5. So 3, 5, 3, 6, 5. Among these 3, which even infinity is very large. Among this 4, which one is minimum? 3 is minimum. So 3 is minimum means what? Now I'll select this vertex to visit next, which is having the minimum edge weight. Among 3, 5 and 6, 3 is minimum. That's why I selected this edge to this vertex to visit next. Now I visited this vertex. Which vertex you will visit now? After visiting that vertex, you have to list in the first column. So that is what? B. That is A comma 3. How you are visited B? With the help of A. So now to reach the B, you require the edge, and that edge weight is 3. That one you are represented here. After listing here, next once again you have to follow the same procedure, that is the remaining vertices which are unvisited. This is 1 and this is 1. So remaining vertices are unvisited, that is like zeros. What are those? C, F, E, D. So that is what you list here, C, D, E, F in sequence I written. So next you see that. So now for the C, F, E and D, whether these vertices are adjacent to visited vertex or not. If it is adjacent, then what is the weight you have to decide. So now C is adjacent to visited vertex. 1 means visited. Yes, C is adjacent to which vertex? For B, what is the weight? That is 1. So that's why B is adjacent vertex and weight is 1 here. This is your adjacent vertex. C is unvisited and B already visited. So that's why it is what? So from with the help of the B, you can visit C next. So what is the weight for that edge? That is 1 here. Next D. Is it adjacent to visited vertices? For visited vertices are what? B and A. So now this D is even not adjacent to B and even it is not adjacent to A. Adjacent means, as I told earlier, direct edge from D to A, no. D to B, no. So that's why you have to take this one as what? Dash and infinity. And E. So now E, it is adjacent to A, that vertex you already visited. So, and is it adjacent to B? No, it is not adjacent to B, but it is adjacent to A. So that's why A comma, and what is edge weight? That is 6. That's why adjacent to A, which you already visited, and edge weight is 6. Next F. See, this F is adjacent to B, which you already visited, and A, that one also you already visited. In this situation, if F is adjacent to more than one vertexes which you already visited, so that among those two you have to compare the edge weights, which edge connects the visited vertex with minimum weight, that one you have to select next. For example, for B, it is adjacent to B, edge weight is what now? It is 4. And even F, it is adjacent to A also, minimum weight is what? 5. So among this two, 4 and 5, which one is minimum? 4 is minimum. So that's why F is B comma 4 here. See, earlier you have taken F as a adjacent to A and weight as a 5, because at that time you don't know that even it is adjacent to B. That's why you are taken in the earlier step as a F of A comma 5. But when you visited this B, then you will get to know that yes, even this F is adjacent to B. So for example, if any one vertex, if it is adjacent to more than one visited vertex, in that situation you have to select the edge which one is adjacent with the minimum weight, that one you have to select. So 4 and 5 minimum is now it is 4, that's why I selected 4 now. After listing these vertices with the adjacent and also the weights, next step is what? You have to decide so which edge weight is minimum. So now here 1, 4, infinity and 6. So among this 4, which one is minimum? 1 is minimum. So means what? Now I'll select this vertex to visit next. So that's why I highlighted this part, and I'll visit this vertex also. Now I'll make this one also as a 1. I visited this vertex now. So now after visiting that vertex, you have to write that vertex in the first column. So that is C, B, comma 1 here. So after visiting the A, B, C, now what are the vertices are left as unvisited? That is the F, E, D. So now you list those things in the second column as a unvisited. D, E, F. Next to your work is what? You have to check adjacent to visited vertex. D. Now it is adjacent to one of the visited vertex, that is C here. So that's why here you have taken as a D, C, comma, and what is the weight now? It is 6. Next is E. So now E is adjacent to only one vertex A, and what is the edge weight? 6. So F, it is adjacent to both B and A, but among 4 and 5 edge weight, 4 is minimum. So that's why I selected B as a adjacent to F as a visited one. So B, comma 4 here. After listing, what is the next step? You have to decide among all these 3 vertices edge weight, which edge weight is minimum, that vertex you have to select next to visit. So 6, 6, 4. 4 is minimum. So that's why you select this vertex to visit next. So now I selected and I visited that vertex also. So after visiting, I'll list that one in the first column, that is F of B comma 4 here. So now how many vertices left as unvisited? 2 vertices, E and D. So that's why D and E are unvisited. Next your work is what? You have to check adjacent for the visited vertices. See, now D is adjacent to C and also it is adjacent to F, which are visited vertices. That's why I marked as a 1. 1 means visited. So now this D is now adjacent to F and also adjacent to C, which one you already visited. So now if it is like this situation, if it is there, then you have to select which vertex you will select to as adjacent based on weights. So among these two, 6 and 5 are the weights. So 6 and 5. So now 6 and 5, if it is weight, among these two, which one is minimum? 5 is the minimum. So that's why, so, so for the D, so now among 5 and 6, 5 is the minimum. So that's why when it is minimum, if I take F as a visited adjacent one, then it is minimum weight is 5. That's why adjacent vertex F, which already visited, and weight of that one is 5 here. Next E. So now once again E is adjacent to F, which you already visited, and it is also adjacent to A now. So now once again among these two edge weight, which one is minimum? 2 is minimum. Then you select this one as a adjacent to E. So now E adjacent vertex for the E is F with the edge weight is 2 here. After listing, next step is what? Among these two, you have to decide which one is having the minimum edge weight. So 5 and 2 minimum is what? 2. So now you have to select this vertex to visit next. So that one only you are selected. That one you make as a bold now. So now it is what? This is already you are visited A, B, C, F, and now you are visiting the E now. So whenever you visit that vertex, you list in the first column. And how many vertices are left as unvisited now? These vertices you already visited. Now how many vertices? Only one vertex it is left as unvisited, that is D. Next step is, so adjacent to visited one. So now see D, it is adjacent to visited vertex C and F and also E. If that is the situation, you have to select any one vertex as a visited with the minimum weight. So among 8, 5 and 6, which is minimum, 5 is the minimum. So now I'll take this one as a adjacent to D. That's why here adjacent vertex is F and weight is 5 here. After listing, you have to decide which one is having the minimum weight. This is having the minimum weight. That's why you will write that as a, select the next to visit. After visiting, you write that one in the first column D, F, 5 here. So now this is what? All the vertices you are visited. Okay. Now all the vertices are visited. After visiting, you check out the solution. That solution is the spanning tree only and it is minimum. See, now this is all the vertices are connected. S or no? S. So in the graph, all the vertices are connected and that one only you are highlighted using the bold here. And you check the weight also. Weight is what now? 3 plus 4, that is 7. 7, 8. 8 plus 5. 8 plus 5, it is 13. 13 plus 2, 15. So now for this graph, minimum spanning tree weight is what? 15. So it is the optimal solution only. I hope that you got the procedure. So now this is the one way of finding the solution using Prim's algorithm. See how many solutions you got now? Only one solution, and that solution is what it is? It is minimum spanning tree. It is optimal. So this is the how actually greedy procedure works. And as I told earlier, first you have to make concentration on what? Condition. What is the condition here? Minimum spanning tree. So that's why on every iteration you are concentrating on minimum weights. For example, here 3, 6, 5, you are selected 3 based on what? Based on the condition. That is your first step. So in the greedy method, first step is what? It must be feasible. Concentrate on condition. So now we are concentrated on condition, that is the feasibility as a minimum criteria. And next one is the optimal. So yes, at the end you got the only one solution, that is the optimal. And irrevocable. See, on every iteration, in the first iteration, this vertex is visited In the second iteration, this vertex you are finalized. See that one, whatever the vertices you are finalized, all those things are you are highlighted. Or you are changing those highlighted edges? No. At the end also you got the same thing here. Means what? On every iteration, what are the solution you will got? No, that solution is fixed. So now you are not changing those solution in the next iteration. That is what you call as a irrevocable. So in this way, you will find the solution for the problem. So what is your problem now? Finding the minimum spanning tree. So you got that minimum spanning tree here. I hope you got the concept how actually Prim's algorithm works to find the minimum spanning tree under greedy method. Thank you.